Hello everyone, welcome to the study of OD. We are looking at the non-homogeneous part and we are considering the method of undetermined coefficient. So you are going to solve this. D squared plus 4D plus 4 is equal to exponential equal to 2 exponential negative 2x. Note that D squared is the same as y double prime and the D single prime is the same as y single prime. So this has two parts. It has the complementary part. So for the complementary part, we are going to consider the reduced form of the OD, which become D squared plus 4D plus 4 is equal to 0. So to solve this, we let our y to be equal to exponential mx. From here now, you get your y single prime. You differentiate this to get your m exponential mx, and you get your y double prime, which gives you m squared exponential mx. Then you substitute the value of d here. Note that we have seen that d squared is the same as y double prime. So we substitute them here. Instead of d squared, we write m squared plus 4m plus 4. I have factored exponential m x. This is equal to 0. Now note that here, exponential mx cannot be equal to 0. That one can never be equal to 0, meaning that this part, m squared plus 4m plus 4 is equal to 0. This is a quadratic equation which can be factorized to give us the following. So this can be factorized as m plus 2. We square this, which is equal to 0. Now, when you solve this, you are going to find out that our m1 is equal to m2, which is equal to negative of this part here. So it is a repeated part. So the solution of our complementary part, yc, will be given by c1 exponential negative 2x plus c2x exponential negative 2x. Or now we arrive at this, you can check in my YouTube channel, whereby we have looked at homogeneous part, whereby now you have the root repeated. We have seen how we write it in this form. So this can be written as c1 plus c2x exponential negative 2x. Now, to get the particular part, yp, we are going to attempt this form, a x squared exponential negative 2x. That is what we are going to use because there is x there. So that's why we are considering the part with let yp to be equal to a x squared exponential that. Then from here now we get our y prime. We differentiate this. This is product row to x exponential negative 2x minus 2a x squared exponential negative 2x. We obtain y double prime, which will give you, so you differentiate this will give you 2. There is a 2a exponential negative 2x. You differentiate again to get negative 4 x a exponential negative 2x. Then here you differentiate x squared minus 4 ax exponential negative 2x. Then my plus, because of this negative, 4 ax squared exponential negative 2x. Here you can see whether there are like terms. You have this and this. So this reduces to 2a exponential negative 2x minus 8ax exponential negative 2x. Combining these two plus 4ax squared exponential negative 2x. Then we are going to substitute this to our given your OD. OD was y prime. plus 4y prime, y double prime plus 4y is equal to, on the other side, 2 exponential negative 2x. So you substitute all these values there. So y double prime, it is 2 a exponential negative 2x minus 8ax exponential negative 2x plus 4 ax squared exponential negative 2x plus 4 into bracket. Y single prime is here, 2x exponential negative 2xa minus 2ax squared exponential negative 2x plus 4x squared exponential negative 2x. This is equal to 2 exponential negative 2x. When you observe this keenly, you have here 8ax exponential negative 2x, and here you have 4 multiplied by 2x. So this will be 8 negative and the positive. This part here will cancel with the other part here. Then you have this other part here, 4ax squared, and this other part here, which is 8. And here you will have this 4, and this other part here, which will give you negative 8. So that part will cancel. So you are going to be left with 2a exponential negative 2x, which is equal to 2 exponential negative 2x. Meaning that our 2a is equal to 2, which implies that our a is equal to 1. So that particular part to be, so now our particular part, which we are related to be a x squared exponential negative 2x, will become x squared exponential negative 2x, since we have obtained our a to be equal to 1. Our a is equal to 1. So our general solution, y is equal to y complementary plus y particular, which is equal to c1 exponential negative x plus c2 x exponential negative. This is 2x, sorry. We found this to be 2x plus x squared exponential negative 2x. So that is our general solution of the given ODE. Thanks so much for taking your time to study with me. For more examples, tune in to my YouTube channel so that we may continue learning together.